to discuss part 3 question answer video. Next question is establish the relation between electric field and potential gradient. Means we have to drive the relation E is equals to minus dV by dr. So we can do what? Let us consider two closely spaced equipotential surfaces A and B. This is surface A, lower surface. This lower surface is A. This upper surface B. Where A is at potential V and B is at potential V minus dB. Means this is at high potential, this is at low potential. So field is always from, so we have two alternatives, that E is always from positive to negative, or we can also say it in alternative way that E is always directed from body at high potential to body at low potential. So if we have two equipotential surface, this is potential equipotential surface A, this is the equipotential surface V, where A is at potential V and other is at V minus dV, then field is from A to B. Let they are separated by a distance dr with each other. Dr is the perpendicular distance between the two equipotential surfaces. So if you want to move a unit positive test charge from surface B to A, means we have to do work against the external electric field. We have to do work against this electric field. So work done is equals to E dot dr. Work done is equals to minus E dot dr, where potential difference between them is dVA minus VB, where VA is V and VB is V minus dV. So this is also formula of work done, that charge is unit positive, so its magnitude is 1, so VA minus VB only left here, that is equals to dV. By comparing equation 1 and 2, we get dV is equals to minus E dr. So from here we get E is equals to minus dV by dr. So this term is called negative gradient of potential. Negative gradient of potential. Next question is, this question is actually the topic that we already have covered. This next all question are the topics, like we already had discussed about the derivation of electric potential due to point charge. So that the derivation is in question form. Find the electric potential due to point charge. So you can do it from there also. Next, that we already had done, that equipotential at equatorial point on an electric dipole or axial line or axial point of an electric dipole, that you have to do by yourself. This is the system work done, electric potential energy to assembling a system of two charge Q1 and Q2 in presence of external field. That this cases actually we have discussed. Now I am just added this images to the PDF so that I can tell you how they can ask that derivation in form of questions. Next is derive the expression for potential energy of electric dipole of dipole moment P in electric field. This all we had done. Potential energy that we find it, that was equals to U is equals to P dot E. Really sorry for this. U is equals to potential energy, U is equals to P dot E, and torque, that is equals to P cross E. We already done this. Next question, a test charge Q is moved without acceleration from A to C along the path A to B, then from B to C. Find the or calculate the potential difference between AC, at which point is electric potential more and why. So we have to just find the potential difference. Potential difference is between A and C. So C is at high potential, so we have moved from A to C, so its potential difference is VC minus VA. or potential difference is equals to E dot dr or dl. As field is in this direction and we have to apply force or displacement in this direction, so there is a negative sign, and angle between them, so this is actually according to the formula, so angle between them is 180 degree, because E is in this direction, dl is in this direction, so angle between them is 180 degree. So by solving this, we'll get E into 4, that is 4E. So VC is equals to VA, 4E, so it means VA is greater than, VC is greater than VA, or VA is less than VC, because direction of electric field is in decreasing potential. This last question of this PDF. Next question is, a point charge Q is placed at O as shown in the figure. Vp minus Vq is positive or negative, justify your answer. This is same as question that we already done in the previous video.